Hello everyone and welcome back. In today's video, I'm going to show you how to solve this problem. Let's look at the problem. A daredevil on a motorcycle leaves the end of a ramp with a speed of 35 meters per second as shown in the figure here. If his speed is 33.0 meters per second when he reaches the peak of the path, what is his maximum height that he reaches? And in this problem, we are going to ignore friction and resistance. Now let's dive into the solution. To solve this problem, we are told that a daredevil launches off the end of a ramp at 35.0 meters per second and then reaches a final speed of 33.0 meters per second at a maximum height. This problem here, by first looking at it, most physics students would think, let me start using kinematics. But you cannot use kinematics. Why? Because we are not given the initial launch angle, theta, because this initial speed is going to be at an angle with the horizontal. We need to resolve this speed, but we don't have the angle, so doing that is going to be a challenge. Another thing we need to note is that for kinematics, we should be able to find the time interval for this motion using one of the components of this motion. Kinematics in this problem is not a go-to approach. We are given the initial speed of this motorcycle jump to be 35.0 meters per second, and then we are given some speed at the maximum height or at that peak height, V final, to be 33.0 meters per second. And interestingly, we can see that at the maximum height, kinematics tells us that the vertical speed should be 0, but the horizontal speed is not 0. So if the total speed at the maximum height should add up to the initial speed, then where did the rest of the speed go? Because we can see a difference of 2 meters per second in the speed between the 2 points. So we are going to find out where that speed went. So to solve this, we need to first establish our coordinate system and also draw our free body diagram. Okay, so I'll use the XY coordinate system, which we know as the Cartesian coordinate system, with the vertical axis representing the vertical component of this motion, and then the horizontal axis representing the horizontal component of this motion. So we have y, all right, and then along the x-axis is our horizontal motion. So I'm going to place the origin at this point. So we do have the motorcyclist at this point launching off the ramp with that initial speed in red arrow VI. We know it makes an angle theta with the horizontal, but we are not given any information about the angle. The only information we know is the speed VI at that initial point and also the speed at that maximum height he reached. So these are the only speeds we are given, and with that we are going to solve the final maximum height. So we know the trajectory is going to be, as usual, parabolic until he reaches that maximum height. So now let's call the initial launch point as point A, and then the final point where he reaches that maximum height as point B. All right, since we don't know the angle, let's not use kinematics at all, but the best approach to do is to use the conservation of mechanical energy for this system. What do we know about the system? We are told to ignore friction and air resistance. So if you are to ignore friction and air resistance, then we can apply the conservation of mechanical energy, which says that provided there's no external forces acting on this motorcyclists from the point of launch all the way to the maximum height, then the total energy along that path is always a constant. So since we know that no non-conservative forces such as friction, such as air resistance, then energy total, so E total at point A has to be equal to energy total or the total energy at point B. And this is all we need to solve this problem. So what is the total energy? We need to look at the mechanical energy. That is the potential and kinetic energy put together. So the total energy at point A is going to be the potential energy, gravitational, plus the kinetic energy. So this at point A, and that must be equal to the potential energy, gravitational at point B, plus the kinetic energy at point B. And this is the conservation of mechanical energy. So the only energies we are looking at is potential energy and kinetic energy at those 2 points. The sum of these energies at each point has to be equal. So that's why we are able to equate the total energy at point A to be equal to the total energy at point B. So potential energy, that is the energy possessed by this motorcyclist due to his position, all right? So at point A, his position is at the 0 position. That is the importance of using the coordinate system. So his vertical position at point A is going to be 0. And also that means the potential energy at that point is going to be 0, because potential energy is nothing but the mass of the motorcyclist plus the motorcycle, right, times acceleration due to gravity times the vertical position, y. And in this case, y is 0, so the potential energy at point A goes to 0. Now we have simplified the problem by just eliminating one term for the potential energy at point A. So let's see what comes out of this equation. So now we have the kinetic energy. So at point A, I call it the initial. It should be equal to the potential energy at point B, gravitational, so final, plus the kinetic energy final, that is at point B. And what is kinetic energy? Kinetic energy is the energy possessed by a moving object. So if the velocity is 0, then 0 kinetic energy. If the object has velocity, then the object is moving, right? It is going to have that energy that is causing it to move, all right? And that energy is given to us as 1/2 the mass of the object times the speed squared. So here the speed is the initial speed squared. And that is going to be equal to the potential energy, the gravitational potential energy, which is mg, h final, which is our interest, that is the maximum height reached, plus the kinetic energy final, which is 1/2 mv final squared. Why does he have a velocity at the maximum height? And that is the trap. If you go the kinematics approach, you may think, oh, at the maximum height, the velocity is 0. No, the vertical velocity is 0, but the horizontal velocity remains constant from the beginning to the end of the trajectory. So take note of that, and always, when solving such problems using the conservation of energy at the maximum height, the speed is not 0, but the vertical speed is going to be 0. Now let's look at this. If we can further simplify this equation, we can see that we have mass here, mass here, mass here, so those can cancel out, all right? So it's kind of dividing through each of these terms by m. So that will cancel out to 1, and 1 times everything would be just the same thing. Okay, so now we are left with 1/2 v initial squared is equal to g h final plus 1/2 v final squared. Now we still do have fractions, and we want to get rid of the fractions. We can multiply each term by 2. So doing that, we have 2 times 1/2 vi squared, and then we have 2 times GHF, and then we have 1/2 VF squared times 2. And this can also cancel out, because 1/2 times 2 is nothing but 1. And then 2 times GHF is going to be that, and then we have 1/2 VF squared times 2 is also going to be VF squared. So now we are left with VI squared is equal to 2g h final, that's the maximum height, plus v, that's the final speed at point B. Remember that speed is not 0. So v final squared. Do we now see something familiar with this equation? This is actually one of the kinematics equations of motion, and from this we can find our maximum height. So let's find the maximum height. So the maximum height here, we need to isolate it because we have 2g multiplying it. So we have vi squared. Let's move v final squared to the left hand side, and then it subtracts from that. So we are going to have vi squared minus v final squared, and that is equal to 2g h final. So we can find h final by dividing both sides of this equation by 2g. Okay, so we divide here by 2g, and then I have to do same on the left hand side by 2g. We can see 2g cancels out to 1 on the right hand side, multiplying the final height, which is hf, and then on the left hand side we have vi squared minus vf squared divided by 2g. And we know all of these values. We can now comfortably plug them in and determine the final height. So the final height hf is going to be hf equals vi squared minus v final squared divided by 2g. So if we plug in those values, we are going to have 35.0 squared minus 33.0 squared, and then divided by 2 times acceleration of free fall. So 2 times 9.8. So evaluating this is going to give us hf, the maximum height hf, or the final height reached, is going to be 6.94 meters. All right, so this is the maximum height reached by this motorcyclist. However, the key point here to note is that part of the energy is used in giving this motorcyclist that height. And you can only see that using the conservation of mechanical energy. This is my approach to solving this problem. I would love to see the approach you used in solving this problem, and comment it down below. And until then, I'll see you in my next video.